Let us understand the arrangement with an example. Suppose you are organizing a party. We have three men. Let the men be A, B, and C, and there be three women P, Q, R. Okay, three just random men and three just random women. Of course, parties include both men and women. Now, in the party, you have organized a dance, a couple dance that too. That is, one man will dance with one woman. Okay, so I'm asking you, how many ways can these three men dance with these three women? One on one. Okay, either A dances with Q, B dances with P, C dances with R, or A dances with R, B dances with P, C dances with Q. How many? In how many ways? Okay, so the answer will be A has three choices, B has two choices, and C has one choice. Okay, A has three choice. If A chooses one woman, then one choice gets decreased for B. Similarly, similar thing will happen for C. So that means the total number of dances that is possible between these three men and three women is how many? Six. Okay, not total number of dances, total number of situations. Sir, I did not understand. I will make you understand now. Okay, for now, just you know that there are six possible ways in which these three men can dance with three women. How and what is the nitty-gritties of it? Let us see now. Okay, so let us see the situation one. In situation one, A dances with P, B dances with Q, and C dances with R. In situation 2, A dances with P, B dances with R, and C with Q. Situation 3, A with Q, B with P, C with R. Situation 4, A with Q, B with R, C with P. Situation 5, A with R, B with P, C with Q. Situation 6, A with R, B with Q, and C with P. There is no other way in which these three men can dance with three women. One on one. Okay, it will not happen such a way that two men dance with one woman or one man dance with two women. It does not happen like that in this situation. In this dance that you are organizing. Okay, fine. Now I am giving you one information which I did not give previously. That information is actually these three men and these three women are not just very random women or men. Okay, A is actually married to Q, B is actually married to R, and C is actually married to P. This changes everything. So how? I will explain you. Previously what you have done is, without considering for the fact who is married to whom, you have given six possible ways in which this three man is dancing with this three woman. Okay, without disregarding the fact that A is married to Q, B is married to R, and C is married to P. Okay, fine. Let us analyze it. Sir, what is happening? Let us analyze it. The first situation, okay. A is dancing with P, B is dancing with Q, and C is dancing with R. Whereas A is actually married to Q, B is actually married to R, and C is actually married to P. This is totally wrong. None of the men is dancing with the woman who he should dance with. Okay, because in an ideal situation, a man dances with his or her. He's not. He's a man in an ideal situation. A man edit. A man dances in an ideal situation with his woman only, not some other's woman. Okay, or a woman dances with her man only, not some other man. Okay, so in this situation one, none of the men is dancing with the woman he is supposed to be. So that means I will represent it something like this. All three are wrongly dancing. All three are wrongly dancing, or 3W. I will explain this notation later on, but just for now, just understand it. In this situation, A is dancing with P, B is dancing with his wife, and she is dancing with Q. That means here at least one, exactly one is dancing correctly. So one right and two is dancing wrongly. Similarly, in this situation, A is dancing with Q, B is dancing with P, C dancing with R, which is B and C are not dancing with the one that he or they are supposed to be. So that means here also one is right, A is dancing correctly, and two wrong. Similarly, this one, each of them are dancing with the one woman that they are supposed to be. So that means all three are rightly dancing here. Here R, P, Q, again all three are wrong. Here R, Q, and P, one right and two wrong. Okay, so let me summarize what we have obtained till now. We have obtained that till now, first of all, we saw that three men can dance in six ways with three women. Okay, there are six possible ways, six possible situations in which these three men can dance with three women. Now, if we have given the information that A is married to Q, P is married to R, and C is dancing with P, C is married to P, then only one, and obviously, of course, one, obviously, only one situation will have the men dancing with their correspondingly correct partner, and all others will be wrong in some way or the other, some more correctness or the wrongness of the situations that we have just seen. In one situation, out of the six situations, in one situation we have all the three dancing correctly. Sorry, all the three dancing correctly in one situation. In three situations we have one man dancing correctly and two men not dancing correctly. And in two situations we have all the three men dancing not correctly, dancing wrongly. Okay, fine. So let us now understand what is dearrangement. Dearrangement is the arrangement of some items in such a way that they are not associated with the one that they are supposed to be. Sir, I did not understand. I will now explain to you. Let us see these two situations where the all three are dancing wrongly. Okay, so let me write in words, then you will understand. Number of ways, number of ways in which all three are dancing wrongly. All the three are dancing wrongly. The number of ways in which all three are dancing wrongly is how much? Two. We have just found out that in two situations all the three are dancing wrongly. Okay, this phrase, all three are dancing wrongly. We can say that we have now introduced. We will say the same phrase, introducing a word dearrangement. That number of ways in which all three are de-arranged. All three are de-arranged, that is two. These two phrases represent one and the same thing. That is, what is de-arrangement? De-arrangement technically means de-arrangement technically means that you have to arrange in such a way, arrange in a way such that such that nothing gets rightly distributed. Nothing gets rightly distributed. Sir, please explain once more. I'll explain it once more. Just see. Initially, we found that there are six possible situations in which these three men are dancing with these three women. Alright. After introducing the fact that A is actually married to Q, B is actually married to R, and C is actually married to P, we found that only in one situation, all the, sorry, not this situation, in this situation, all the three men are dancing with the woman that they are supposed to be. Okay, and in all the other situations, some degree of error is happening. Okay, in some situations, more error than the other situations, because in other situations, at least one of them is dancing correctly. Not this one, sorry, I'm just doing error once again. In the other situations, at least one of them is dancing correctly and the two are dancing wrongly, whereas in two situations we have all the three of them dancing wrongly. Okay, so the number of ways in which all of them, all of the men are dancing wrongly, that means arranging in a way such that nothing gets rightly distributed, all of them are dancing wrongly, is called dearrangement, in which all three are dearranged, all three are dearranged, all three are dearranged, all three are dancing with the woman that they are not supposed to be. None of them, not a single one of them is dancing with the woman that they are supposed to be. That means we have dearranged three of them. The number of ways in which all three of them are dearranged are two. There are two ways in which all three of them are dearranged. Hence, we'll call it two, and this is also written as D2. Not, sorry, not D2, D3. D3 means what? Number of ways in which three things are dearranged. So the number of ways in which three things are dearranged is 2. Do not confuse this 3 and 2. Again, I'm repeating it. How many things are getting dearranged? 3. So we will see this as D3. In how many ways these 3 are getting dearranged? 2. Okay, this is the final answer. How many things are getting dearranged? 3. How many ways in the are there in which these three items are getting dearranged? 2. Okay, things and number of ways. Fine. So D3 is 2. Let me give you one more example. Okay, one more example. Let me explain it further. I will come to D3 once again. Don't worry about it, sir. What does D means and all? It's just a notation. Okay, just a notation, nothing else. Let me give you one more example so that it is more correct, more clear, crystal clear for you. Like for example, we have two postcards. Okay, we have two postcards. Let this be P1 and P2, and let us suppose that we have two addresses. Okay, just random addresses M and N. Okay, random addresses. So you are asked that in how many ways these two postcards can be sent to these two addresses, not knowing which postcard is actually meant for which address. We do not know if postcard 1 is meant to go to M or N. Just you have been asked in how many ways these two postcards can be sent to these two addresses. The answer is what? 2 into 1? 2? Only two ways? Only two ways, which can be very easily manually written also. The way number 1 or situation 1, when P1 goes to M and P2 goes to N. Way number 2, when P1 goes to N and P2 goes to M. Fine. Okay, great. Now you have been given the information that actually P1 was meant to go to M and P2 was meant to go to N. P1 was meant to go to M and P2 was meant to go to N. That means this way was actually the correct way. All two are going the way that they are supposed to be. And in this way, none of the postcards are going to the address that they are supposed to be. That means they all two are wrong. Okay, so all two are wrong. So you have been asked in how many ways is two things getting dearranged? The answer is what? Only in one way. Only in one way. This way only. Okay, this way only. Have two ways. Only in one way our two things are getting dearranged. Fine. Okay, now after understanding what is dearrangement, we will introduce the formula for dn. Okay, so d3 you have got 2, d2 you have got 1. Now you have been asked what is d4. That means if four things are getting dearranged, how many number of ways, in how many number of ways four things can then get dearranged, in or in how many number of ways five things can get dearranged. Okay, so the formula for dn, we have a formula for dn which will be derived in a later video of mine, but in this video I'm just introducing the concept of dearrangement, trying to make you understand what is do you mean by dearrangement, and then introducing the formula for dn. The formula for dn is very easy: n factorial bracket 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial up till 1 by n factorial. You have to go up to that factorial as there are number of things, as there are number of things that you need to dearrange. For example, you have to dearrange five things. You have been asked in how many number of ways can five things can be arranged. The answer is simply 5 factorial 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. Okay, so if I calculate this one, it's very easily calculated. 5 factorial, this gets cancelled, and the other is 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. So if I calculate this one, so this one is 5 into 4 into 3 minus 5 into 4 plus 5 minus 1. So this is 60 minus 20 plus 4, hence 44 ways. 44 ways. Fine. And we can easily see from this formula that d3, what is d3? D3 is 3 factorial by 1 by 0 factorial minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. If we calculate this one, if we calculate this one, this will be 3 minus 1 2, and which we've already found out d3 is 2. Similarly, you can find out d2 from this formula. Just put n, value of n as 2, you will get d2 as 1. Okay, great, understood. One thing that is a very great observation. Okay, in the very first situation, very first scenario that we saw, that is three men dancing with three women, we had six possible situations in which one situation all three men are dancing with the woman that they are supposed to be. In three situations, only one of the men is dancing with the one woman that he is supposed to be, and in two situations all three of them are dancing with the women that they are not supposed to be. Okay, understand one thing, you can have a question now. Look, three of them are dancing correctly, one of them is dancing correctly and two are dancing wrongly, and three of them are dancing wrongly. Why there is no a possible way, there is not a way in which two are dancing correctly and one is dancing wrongly? Try to understand. There is one way at least when all three of them are dancing correctly. There is three ways in which one of them is dancing correctly and two are dancing wrongly, and there are two ways when neither of them, none of them are dancing correctly. Why is there no way in which two of them are dancing correctly and one of them is dancing wrongly? Because that is technically not possible. Technically this is not possible. There are zero ways in which two of them are dancing correctly and one of them is dancing wrongly. Because think about it, think about it. For example, two of them are dancing correctly. For example, let A dances with correctly with Q and B dances correctly with the one woman that he is supposed to be. C has to dance with the woman that is left behind, P, which is happens to be his wife. That means if you have arranged two of them correctly, the third one automatically becomes correctly arranged. That means in no way you can have two of them arranged correctly and one of them arranged wrongly, because arranging two of them correctly automatically correctly arranges the third one. Fine. Good. All good. Let us do a question. Let us do a question to understand it further. We have a question. We have five letters, five postcards or letters, five letters, which is supposed to go to five addresses. Okay. You have been asked, find number of ways, first, and all letter goes to wrong address. When all letter goes to wrong address, very easy. Very easy. Five letter goes to five addresses, like letter 1, letter 2, letter 3, letter 4, letter 5, A1, A2, A3, A4, A5. That means what is it saying? That all letter goes to the wrong address. That is, none of the letters goes to the one address that he or she is supposed to be. Let L1 is supposed to go to A1, L2 is supposed to go to A2, L3 is supposed to go to A3, L4 is supposed to go to A4, and 5 is supposed to go to A5. That is my consideration. That is my let. That is, I have let L1 go to A1. You can also let L1 go to A2. It is your choice completely. Okay, but it is my, it for convenience, that I have chosen L1 to go to A1, L2 to go to A2, L3 to go to A3, L4 to go to A4, L5 to go to A5 correctly. This is the correct arrangement. Okay, I have not yet introduced the wrong address right now. I have just told you that L1 was supposed to go to A1, L2 is supposed to go to A2, L3 is supposed to go to A3, L4 supposed to go to A4, L5 supposed to go to A5. Now the question is asking you, find a number of ways in which all the letters are sent into wrongly. That means number of ways in which L1 is not sent to A1, L2 is not sent to A2, L3 is not sent to A3, L4 is not sent to A4, L5 is not sent to A5. So what is the number of ways? That means what we are doing is actually we are dearranging all the five items. So answer is D5, which I've just found out previously, that is 44 ways. Fine. B part. In B part, find a number of ways, in which exactly three letters goes to wrong address. Okay, exactly is a important keyword here. That means exactly three letter goes to wrong address. Again, I am copying this. What we have is exactly three letters goes to the wrong address, which indirectly also means that exactly two letters goes to the right address, goes to the right address. So exactly two letters. Okay, so now for us, you can understand that exactly two letters, that means that exactly two letters can be any two letters, right? It can be L1 L2, it can be L1 L3, it can be L1 L4, it can be L1 L5, it can be L2 L3, it can be L2 L4. Any two letters out of these five letters, any two letters out of these five letters, any two letters out of these five letters. By 5C2 we have selected any two letters out of these five letters. Okay, let us select L1 and L4. We have selected any two letters out of these five letters. This 5C2, that means two of them we will send to the right address. Fine, we have sent to the right address. Okay, we have taken these two letters L1 L4 and we have sent to the address that they are supposed to be. That is, L1 has gone to A1, L4 has gone to A4, and the remaining three we need to dearrange. The remaining three we need to dearrange. This is your final answer. 5C2 into D3, 5C2 into D3, that is 10 into D3. You can calculate it, it will be 2, so 20 ways. So exactly three letters goes to the wrong address. Fine. C part. at least at least four letters, at least is the keyword here, four letters goes to right address, at least four letters goes to right address. This can be solved purely by common sense, but first of all, just to illustrate you how mathematics is nothing but common sense, I will solve it purely mathematically and then I will link it to the purely common sense. Okay, so what the C part is asking is, we have five letters that is supposed to go to five address, and we want at least four letters going to the right address. So at least four letters going to right address means that exactly four letters goes to right address, goes to right address, plus exactly five letters goes to the right address. Fine. So that means exactly four letters. That means out of the five letters, we select any four letter, and the remaining one letter we send it to the wrong address. Fine. Similarly here also, out of the five letters we take five letters, and all the five letter we send it to correct address. That means we are dearranging none of the letters here. All the five letters are supposed to go to the right address. Fine. So let us calculate 5c4. 5c4 is 5. D1. D1 is 1 factorial by 1 by 0 factorial minus 1 by 1 factorial plus 1 into D0. 0 factorial 1 by 0 factorial. So here these two can cancel. This is 0 plus this is 1. So there is only one way in which at least 4 letter goes to the right address. Okay, this is the mathematical answer. Now let us answer this using purely common sense. From here only you can see exactly four letters goes to the right address. Think about it. Exactly four letters goes to the right address. That means four letters are going to the right address and one letter is going to the wrong address. And I have just explained to you previously that if we are sending four letters correctly, it automatically happens that the fifth letter goes to the right address automatically. That means there is zero ways in which exactly four letters goes to the right address. Exactly means that only four, not more than four. That means this meant that exactly four goes to right and one goes to wrong. One goes to wrong, and I have just told you that it is not possible for four letters going to the right address and one letter going to the wrong address. It is not possible. So this answer is 0. 0 and plus exactly 5 letter goes to the right address. So all the five letters goes to right address only one way. There is only one way of sending the five letters to the address that they are supposed to go. So there is only one way. Finally, final answer.